Good day to you children. Let's continue from where we left in the last class. That is exercise 4.4, fourth main question. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. So as you can see in the figure here, we have a circle with center O and AB is its diameter. We have drawn two tangents at the endpoints of the diameter, that is at point A and point B. We have drawn two tangents xy and mn respectively. Our job is to prove that xy and mn are parallel. To do this, we will be using the properties of parallel lines. So first, let us write down given circle with center O, circle with center O, and AB is the diameter. XY is the tangent at A and MN is the tangent at B. Now to prove XY is parallel to MN. So proof angle XAO is equal to 90 degrees. That is this angle. It is 90 degrees because we know that XY is a tangent and A is the point of contact, OA is the radius. Then we know that the tangents are perpendicular to the radius at the point of contact. So tangents are perpendicular to OA. Similarly, name this as result 1. Similarly here, angle NBO is equal to 90 degrees because MN is perpendicular to BO. BO or OB is the radius. Name this as result 2. So now both the angles are equal to 90 degree and they are equal to one another. From 1 and 2, angle XAO is equal to angle NBO is equal to 90 degrees. So here you can see we have two lines and AB is our transversal. We get that our alternate interior angles are equal to one another. So from the properties of alternate angles, it says that if the alternate angles are equal, then the lines are parallel. So this implies AB is a transversal to lines XY and MN where alternate angles are equal. Therefore, XY is parallel to MN. You learned this in 9th standard. Hence, proved. In the 5th question, we have prove that the perpendicular at the point of contact to the tangent to a circle passes through the center. So this is the converse of the first theorem which we proved. In the first theorem, we proved that the tangent is perpendicular at the point of contact to the radius. So radius always comes from the center. So here we are going to prove converse. If it is perpendicular, then prove that it passes through the center. Here we have our circle with center O and XY is the tangent and the point of contact is P. So OS is the perpendicular here to our tangent. So given XY is the tangent with P being the point of contact. Also, we know that OS is, we don't know, we have to prove that it passes through O. So don't say OS. Also SP is perpendicular to XY. We have to prove that this SP passes through O. So we know that SP is perpendicular to XY. Now to prove that SP also passes through O, let us first use our first theorem. We know that OP is perpendicular to XY. OP is perpendicular to XY from our first theorem, right? We know that OP is perpendicular to XY from our first theorem. Similarly, angle SPY is equal to 90 degrees, because this is given. We know that the perpendicular to the they have told us that it is perpendicular to the tangent. So this angle is also 90 degrees. This angle is also 90 degrees, and we know that this angle is also 90 degrees. So here this implies, since OP is perpendicular to XY, angle OPY is equal to 90 degrees. This is result 1 and this is result 2. Add 1 and 2. We get angle OPY plus angle SPY is equal to 90 degrees plus 90 degrees is equal to 180 degrees. So here we have a line. We have 3 points O, P and S, and when we draw a line passing through all these 3 points, and there is another line standing on top of these 3 points, then the sum of the angles made by the third line, that is our tangent, is exactly equal to 180 degrees, which is an indication of the linear pair. This implies O, P and S are collinear. That means all the 3 points lie on the same line. Or this implies perpendicular to the tangent passes through the center. Hence proved. We just proved that the 3 points are collinear. That means they lie on the same line. Then when you draw the perpendicular through 2 points, then it will obviously, if you extend it, it will pass through the third point. That was the logic here. So this is the solution to the 5th question. I am leaving 6th and 7th questions for you as your homework. So in the 8th question, a quadrilateral ABCD is drawn to circumscribe a circle. Prove that, just as shown in the figure. The figure has been given in your textbook. Show that or prove that AB plus CD is equal to AD plus BC. AB plus CD is equal to AD plus BC. We have to prove that. So first, ABCD is the quadrilateral given. ABCD is the quadrilateral Here you can see that A, B, C and D are external points to the given circle, and these points where the sides of the quadrilateral meets the circle, PQRS points, they are nothing but point of contact of the tangents, right? So I can write AB, BC, CD and DA are tangents to the circle with P, Q, R and S as point of contact respectively. So also we know that whenever there are two tangents from an external point, then their lengths are equal. So right, AP is equal to AS, BP is equal to BQ, CR is equal to CQ, and lastly we have RD is equal to DS. Name them as equations 1, 2, 3 and 4. And the reason is tangents from an external point. From an external point, they are equal. External point. Now add 1, 2, 3 and 4. We get AP plus BP plus CR plus RD is equal to AS plus BQ plus CQ plus SD. We get, so now AP plus BP is AB, CR plus RD is plus CD is equal to BQ plus CQ is BC plus AS plus SD is AD. So we were supposed to prove AB plus CD is equal to AD plus BC, hence proved. We just used the simple property of tangents to prove that AB plus CD is equal to BC plus AD in the given circumscribing quadrilateral. In ninth question, in the figure 4.13, xy and x dash y dash are two parallel tangents. Xy and x dash y dash are two parallel tangents to a circle with center O. And another tangent AB with point of contact C intersects xy at A and x dash y dash at B. Prove that angle AOB is 90 degrees. Our job is to prove that this angle is 90 degrees. So to do that, first let us consider solution in triangle APO and triangle ACO. In triangle APO and triangle ACO, OP is equal to OC because they are radii of the circle. OP is equal to OC, radii of the circle. OA is equal to OA, common side. And lastly we have angle OPA is equal to angle OCA because both are right angles. The angles made by the tangents at the point of contact with the radii, they are perpendicular, so 90 degrees. So by RHS, triangle APO is congruent to triangle ACO by RHS. So this implies, in these two triangles, this implies this angle is equal to this angle. So angle PAO is equal to angle CAO. This is result 1 by CP, CT, corresponding parts of congruent triangles. This is result 1. Similarly, in triangle BQO and triangle BCO. But before that, since these triangles are equal, that is CAO is equal to PAO or PAO, I can write angle PAC is equal to 2 times angle CAO. This is my result 1, not this. This is my result 1. Why? Think about it. Now coming to the triangles at the bottom part, that is triangle BQO and triangle BCO, following the same logic. OB is equal to OB, common side. Then angle BQO is equal to angle BCO because they are right angles. And lastly, OQ is equal to OC because they are radii of the circle. So this implies triangle BQO is congruent to triangle BCO by RHS rule. So this implies these two angles, that is angle OBC is equal to angle QBO because by CPCT, that is corresponding parts of congruent triangles are congruent, or CPCTC or CPCT. And this implies, since these two angles are equal, then angle QBC is equal to 2 times angle OBC. This is result 2. We also know that XY is parallel to X dash, Y dash, and AB is a transversal. If you look at the figure, you'll know. Look here. XY is parallel to X dash, Y dash, and AB is one of the transversal. Of course, PQ is a transversal, but AB is also a transversal. And these two angles, angle PAC and angle QBC, these two bigger angles are the interior angles on the same side of the transversal. So this implies angle PAC plus angle QBC are supplementary, that the sum is 180 degrees because they are interior angles on the same side of transversal. Another name for these angles is co-interior angles. You can also write the reason as co-interior angles. From 1 and 2 we can substitute angle PAC as 2CAO plus 2Q, and QBC is 2OBC. 2 times OBC is equal to 180 degrees. So this implies angle CAO, take 2 as common, plus angle OBC is equal to 180 degrees by 2. 2 ones are 2 90s are. So the sum of the two angles, the sum of these two angles, that is angle CAO and angle OBC, is 90 degrees. So name this as result 3. Now in triangle AOB, we are supposed to prove that angle AOB is 90 degrees. So in triangle AOB, angle AOB plus angle CAO plus angle OBC is equal to 180 degrees because these three angles are the interior angles of the triangle. So by angle sum property, their sum is always 180 degree. So we know that from 3CAO plus OBC is 90 degree. This implies angle AOB plus 90 degrees is equal to 180 degrees from result 3. So this implies angle AOB is equal to 180 degrees minus 90 degrees. So this implies angle AOB is equal to 90 degrees. This was the result which we were supposed to prove, so hence proved. This is the solution to the 9th question from your exercise 4.2. The 10th question is something which we have utilized. We have applied the result of this question in our first few questions from this exercise, that is question number 2 and question number 3. We have utilized the result of this question in our answers. So here the question is, prove that the angle between two tangents, that is this angle, the angle between two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segments joining the points of contact at the center, that is this angle. So we have to prove that these two angles are supplementary. That means their sum is 180 degrees. So here first, given, since we are proving something, let us do it according to steps. Given circle with center O, AP and AQ are tangents, OQ and OP are radii. So these angles APO and angle AQO are 90 degrees each. So to prove angle PAQ plus angle POQ is equal to 180 degrees. Supplementary means the sum of those two angles is 180 degrees. The opposite of this, when we say complementary, it means sum of the angles is 90. When we say supplementary, the sum of the angles is 180 degrees. So to prove PAQ plus angle POQ is equal to 180 degrees. Proof. APOQ is a, you know that it is a quadrilateral. So this implies angle APO plus angle POQ plus angle AQO plus angle PAQ is equal to 360 degrees by angle sum property. Whenever you add interior angles of a quadrilateral, then their sum is 360 degrees, whereas for triangle the sum is 180 degrees. Your 7th and 8th standard mathematics. So here we know that APO and AQO are 90 degree each. So this implies 90 degree plus angle POQ plus angle PAQ plus 90 degree is equal to 360 degrees. Because write the reason, tangents perpendicular to radii or the radius. So this implies 90 plus 90, 180 degrees plus angle POQ plus angle PAQ is equal to 360 degrees. So this implies angle PAQ plus angle POQ is equal to 360 degrees minus 180 degrees. So this implies angle PAQ plus angle POQ is equal to 180 degrees. So this was the result we required, hence proved. This is the solution for the 10th question from your exercise 4.2. In the 11th question, we are supposed to prove that a parallelogram circumscribing a circle is a rhombus. So before we go ahead to the proof, you need to understand what is a parallelogram and what is a rhombus. Parallelogram is a closed four-sided polygon in which all the the opposite sides are parallel and equal to each other, whereas rhombus is a special case of the parallelogram where not just the opposite sides are parallel but all the sides are equal to each other. When a rhombus has all angles 90 degrees, you will get a square. So that is the main difference. If you just talk about parallelogram, and when the parallelogram has all angles right angles, then it will become a rectangle, whereas when a rhombus has all right angles, then it will become a square. So that is the main question here. So here we know that PQRS is a parallelogram which is circumscribing the circle with center O. A, B, C, D are the points of contacts. So here, since it is a parallelogram, we already know that PQ is parallel to SR and PQ is equal to SR because opposite sides. Same thing goes for PS and QR. PS is equal to QR. We already know that. To prove that it is a rhombus, we need to prove that these adjacent sides, that is SR is equal to QR and PQ is equal to PS. Once we prove that all the sides are equal, then it is a rhombus. That is the thing we have to do here. So first, let us write down given PQRS is a parallelogram. Construction join PR, OD, OS and OC. Now in triangle OCP and triangle ODR. Angle OCP is equal to angle ODR is equal to 90 degrees. First, these triangles are equal. Then OC is equal to OD because they are radii of the circle. And lastly, we have PO is equal to OR because it is the diagonal of the parallelogram. Diagonal. So this implies triangle OCP is congruent to triangle ODR by RHS congruency. So since these two triangles are congruent, we can confidently say that this side is equal to this side. So this implies DR is equal to PC. This is the first result. And similarly, DS is equal to SC because this is the second result because they are tangents from external point. See here. S is the external point. So DS is equal to CS or SC. So add 1 and 2. Add both the equations. We'll get DR plus DS is equal to PC plus SC. So this implies RS is equal to SP. RS is equal to SP. That means one pair of adjacent side RS is equal to SP, and also we know that RS is equal to PQ because it is a parallelogram, opposite sides are equal, and since RS is equal to SP, SP is also equal to RQ because opposite sides. So this implies RS is equal to SP and PQ is equal to PR. All the sides are equal. So this implies RS is equal to SP is equal to PQ is equal to QR. Since all the sides are equal, the parallelogram is a rhombus. This implies PQRS is a rhombus. Not just all the sides are equal, but they are parallel to each other. So PQRS is a rhombus. This is the solution for your 11th question. So in the 12th question, a triangle ABC is drawn to circumscribe a circle of radius 4 cm such that the segments BD and DC, into which BC is divided by the point of contact D, are of length 8 cm and 6 cm respectively. Find the sides AB and AC. So we have a triangle ABC which has circumscribing a circle of radius 4 cm. So since it forms tangent of 6 cm and 6 cm, we will first write given BC is equal to 14 cm, the whole side BC, 8 plus 6, 14 cm. AB is equal to B and AC is equal to C. AC is equal to the whole length, AC is equal to C, and AB is equal to B. Also CD is equal to CE is equal to 6 centimeters. CD is equal to CE is equal to 6 centimeter, and BD is equal to BF, and BD is equal to BF is equal to 8 centimeters because they are tangents from external point. Because they are tangents from external point. So now in triangle, let AE is equal to AF be X. These two sides, they be X centimeter. These two lengths of these two tangents be centimeters. So this implies AB is equal to B is equal to, since this is 6 and this is 8, AB is equal to B, which is equal to AF plus FB. So it is X plus 8 centimeters. And similarly AC, which is equal to C, is equal to AC is equal to C plus EA, which is equal to X plus 6 centimeters. So our job is to find the length X and thereby find AC and AB. So by Heron's formula, using Heron's formula, now using Heron's formula, first we need to find semi-perimeter S for triangle ABC. For triangle ABC, S is equal to A plus B plus C by 2. We know that A is BC. BC is equal to A, which is 14 plus B is X plus 8 and C is X plus 6 whole divided by 2. So on simplification we get 14 plus 8, 22, 22 plus 6, 28, 28 and X plus X, 2X. So 28 plus 2X by 2, which is nothing but 14 plus X. So S is 14 plus X. Now area of triangle ABC is equal to, area of the triangle ABC is equal to S into under root S into, that is 14 plus X into S minus A, that is 14 plus X minus 14 into S minus B, 14 plus X minus 8, and because into bracket, when we open bracket it will become minus, X plus 8 becomes X minus 8, and lastly we have S minus C, that will be 14 plus X minus 6. So on simplification we get this whole thing will be reduced to 14 plus X, 14 minus 14 cancels out, we have into X into plus X minus X cancels out, 14 minus 8, it is 6, and into 14 minus 6 we get 8. So this is what we get. And on further simplification, 14 plus X into 6 8s are 48X. 48 into 14, name this as result 1. Centimeter square is the unit. Name this as result 1. So now if you look at the figure, the whole area ABC has been divided into the area of 3 triangles. That is, the first triangle here we have is triangle OBC, triangle OBC plus triangle this one AOC, and lastly the triangle ABO. So the whole area, the whole ABC has been divided into 3 triangles, that is triangle BOC, AOC and triangle AOB. So we can confidently write area ABC is equal to area BOC plus area COA or AOC plus area AOB. So the whole area has been divided into 3 triangles, and all these 3 triangles have heights. Here we are not going to use Heron's formula, but we are going to use the conventional formula for triangle area of triangles, that is half base, that is 14 centimeter plus height 4 centimeter. Since these are radii and these are tangents, all of them are perpendicular to each other, so they are heights, and all of these heights are equal to 4 centimeter because the radius of the circle is 4 centimeter. So in triangle BOC, its area is half into 4 into 14 because BC is 14 centimeters. Plus in triangles AOC, half into 4 into height is 4 into AC is x plus 6. And lastly we have half into in the triangle AOB, half into 4 into the length BC or AB is equal to C, AB is equal to B, that is x plus 8. So on simplification, 2 1s are 2s are 1s are 2s are 1s are 2s are, we'll get 28 plus 2 times x plus 6 plus 2 times x plus 8. This is our result 2. So now compare 1 and 2. 1 says both are area ABC, so we can equate them. So root of under root 14 plus x into 48x is equal to 28 plus 2x plus 12 plus 2x plus 16. So this implies under root 14 plus x into 48x is equal to 28 plus 12 plus 16. 4x plus 28 plus 12 is 40. 40 plus 16 is 56. So this implies under root 48x into 14 plus x is equal to 4 times x plus 14. I removed 4 from the 4 common. So 4 into x, 4x, 4 into 14, 56. We will get the same thing. So now on squaring we get 48x. This, since it is square root, we will get 48x into 14 plus x as it is equal to 4 square 16 into x plus 14 whole square. 14 plus x or x plus 14, same thing. So this cancels. We'll get, this implies 48x is equal to 16 into 14 plus x. So 16 ones are 16, 3s are, this implies 3x is equal to 14 plus x. So this implies on further simplification we get 3x minus x is equal to 14. So this implies 2x is equal to 14. So we get x is equal to 7. 2 1s are 7s are. X is equal to 7 centimeters. So now we know that AC is equal to, we have to find the sides of the triangle, not just x. So AC is equal to x plus 6 which is equal to x plus 6 which is equal to 7 plus 6 which is equal to 13 centimeters. And similarly AB is equal to x plus 8 which is equal to 7 plus 8 which is equal to 15 centimeters. So these are the sides of the triangles which is circumscribing the circle. So in the last question of our exercise, prove that opposite sides of a quadrilateral circumscribing a circle. So this is our quadrilateral ABCD which is circumscribing the circle with center O. Then we have to prove that the opposite sides, that is AB and CD, subtend supplementary angles, that is these angles COD and AOB are supplementary. We have to prove that the sum of these two angles is 180 degrees. So to do that, first let us write down given ABCD is a quadrilateral with PQRS. P, Q, R and S are the points touching the circle respectively. So P lies on AB side AB, Q lies on side BC, R lies on side CD, and S lies on side DA. So respectively. Now from figure we can see that OA, the line segment OA bisects the angle SOP. This angle, the line segment OA bisects this angle. So from figure OA bisects angle SOP. So this implies, we have named the angles with small letters A, B, C, D, E, F, G, H. So this implies angle A is equal to angle B. So similarly, this is first result. Similarly, angle C is equal to angle D. This is second, because OD bisects angle SOR. Similarly, OC bisects ROQ. We will get angle E is equal to angle F. This is result 3. And lastly, OB bisects angle POQ. We will get angle G is equal to angle H. This is equation 4. You can see that sum of A, B, C, D, E, F, G, H is going to give you a complete angle. So the value of a complete angle is 360 degrees, that is angle around a point. That A plus B plus C plus D plus E plus F plus G plus H is equal to 360 degrees. Angle A, angle B, angle C, angle D, angle E, so angle H. So is equal to 360 degrees because it is a complete angle. So this implies A is equal to B. So I can write 2 angle A plus C is equal to D. So I can write 2 angle C plus E is equal to F. So we can write 2 angle E plus angle G is equal to angle H. So we can write 2 angle G is equal to 360 degrees. So this implies 2 common, we'll get into bracket angle A plus angle C plus angle E plus angle G is equal to 360 degrees. So this implies 2 ones are 180s are. So angle A plus angle C plus angle E plus angle G is equal to 180 degrees. So this implies we want to prove that AOB is equal to angle DOC. You can see that AOB is made up of 2 angles A and H. So here I'll make some replacements or adjustments. Angle A plus, I will replace angle C with angle D. I'll keep angle E as it is and I'll replace angle G by angle H. We will get which is equal to 180 degrees. On rearranging, angle H plus angle A plus angle H plus angle D plus angle E is equal to 180 degrees. So this implies angle A plus angle H is angle AOB plus angle D plus angle A is angle DOC, which is equal to 180 degrees. So this is the result we were hoping to prove, that the angles obtained by the opposite sides of a quadrilateral at the center of the circle are supplementary, hence proved. So this completes your chapter on circles. That's all for today. Thank you.